right? So last time we talked about the concept of REST service that allows computers in the world to talk to each other, right? Using a protocol called HTTP, right? So that is really what we use to build to transfer data for apps, like mobile apps, for web applications. Like when you have a web page, you want to get information, is all data is all transferred back and forth using HTTP, and then the data transferred back and forth using one of the two main format. One is called a JSON, okay, JavaScript uh, notation, and then another one is called XML, right? So these are the two most common ones, JSON and XML. And some computers will support both. So you can actually specify what you need. Okay, say you want to contact a company, say NOAA, the government, the weather service today is going to be a nasty day. We're going to get about a foot of snow. So I'm sure they're very busy. So, you go to, say, Google Play or Apple stores, you will see a lot of weather apps, right? So all those apps are just front end, and the data are coming from NOAA for the most part. Sometimes you can get data from the European um, data centers, but mostly from NOAA. So NOAA would provide the data either in JSON format or in XML, and then you're going to get the data, and then you can um, parse the data. Parse, Parse, basically is um, to to format. When data comes in, is in a particular JSON format. Remember all the key value pairs, and if it's an XML, would be like a tags and values and open text value, closing tag, right? So if you use Java to retrieve the data, then when the JSON package or message come in, then you would have to parse the data so you can extract out the information piece by piece and then form your Java objects, right? And then if you have data to send to another computer, then you're gonna have take your Java object and then turn that into a JSON object and then send over the network. And then the recipient will parse it again, turn it into a format that computer can understand. Okay, so basically we use JSON or XML as a vehicle to format the data and transfer back and forth originally in text. I mean, in ASCII or in Unicode, really Unicode. And then if we care about the security, then we will encrypt the JSON or XML messages. So this way, even if people can intercept the data, then they won't be able to understand it, right? It's harder to unscramble, in other words. Okay, so that's just the idea, right? So what we're going to take a look at today is we're going to just take a look at the in a browser environment, how we can get the data, right? Because browser obviously use HTTP, right? So we can get the data that way. All right, so I'm going to share my screen. Okay, so we used to do an application, a mobile application for 248. And what I want to show you here is this string. You can see that is the the HTTP request. Okay, I sent to the government, actually, is the US government for the data center. So I'm going to put it into a place you can actually see well. So let me see where I'm going to put it. So I'm going to put it in, hold on 1 second. I will put it in a place that you can actually see better, nicely. Actually, I think data.gov, api.data.gov. Okay. Okay, that's one. Okay, there's another one. That's another one. All right, so I have so many. Let me see which one I'm going to show you. Oh, maybe this one. Okay, so here you go. Let me see how I'm going to pull this over to this screen. All right. Before I show you this, actually, just look at my screen first, right? So I gave an address here. So this is the web address, okay? But the address is very long, and but you can probably already tell what this means, okay? So this tells you the protocol. Can you see it? Can you see the typing here, the text here? Can you see? Is it big enough? All right. So you can see we analyzed this right before Monday. We said this is the protocol, right? That means we use HTTP, but this is a encrypted version. This is a security version, so that's why you see the S. Okay, that means secure. And then this is the domain name. Okay, domain name is unique, right? So this is the US government, and then the computer name is API, and the domain name is data.gov. So this identify a unique computer on the internet. Okay, that's really the server which has all the governmental data. Okay, now the computer name is the API. Okay, or we also mentioned this could be an IP address, right? But IP address is very hard to remember. So if I copy this, okay, if I copy this domain name, you see, if I copy this domain name, and then if I show you this, okay, command prompt, and if you pin, so I'm sending a pin signal to that computer, right? So that's the name of the computer on the internet. By looking at this English, you know it's the U.S. government. Okay, that's how we remember. Easy for humans, easy to remember. But what I'm doing is I'm sending from my computer, send a pin message to that computer, see how that computer will respond. Okay, just see if this computer is up and running. Because if it responds, that means it's up and running. If it's not responding, then that means you cannot find that computer. So hit enter. I hit enter. What happened? Gov. Okay, there you go. Now you see I got a pin. I'm pinging this, and it's not responding. Request timeout. You see, I'm sending a ping signal to this computer. Okay, but that computer is not responding, right? But it does tell me something. What it told me is the IP address is this. That's IP address 54.173.26.2. So that identifies that computer's IP address. Okay, who gave me this? Since I think I'm using Optima Online at home, right? So there is a DNS server at Optimum, and that server has a table, and the table has two columns. The first column are the English names of every computer on the internet, and then the second column is the corresponding IP address. So basically, when I hit enter, I'm sending this domain name to the DNS server on Optimum. Optimum tells me, oh, I can tell you the IP address of that computer you want to contact at the government is 54.173.26.2. So that means DNS is working. So the Optimum DNS returned that to me. So now my computer will use this IP address and try to contact the government computer. Okay, but the government computer does not respond. I send 4 pin messages, and government computer just decline to respond. So I don't get anything back, right? Now, when I don't get anything back, it can mean one of two things. One is that computer is down. Okay, it's not up running, so of course it's not responding to me, right? And another possibility is that computer just refused to respond. Okay, play dead. Okay, so he's not responding. So so I can try another one. For example, we can try our college computer, right? So SUNY, oops, www.sunnysuffolk.edu. So when I hit that, see if that will respond. Doesn't seem like a respond either. That's strange, but it does tell me the college computer, the web server, www is the web server, is right. So the 192.72.10.5. So in other words, the college computer for that web server for some reason is not responding to my ping request. Okay, this is not a web request. It's just to send a message, say, hey, how are you? Hi, right? But then the server on our college doesn't want to say hi back. Okay, let me just try another thing. Okay, so we try google.com, and now we got to respond back. So Google reply back saying hi back. That's all it means. Okay, you see all the respond back. So Google's address is this one. They responded the 4 packages packages back saying hi, right? So that tells us, Google is nice, and the government, the computer is not, right? The school computer is not either. Okay, but that's how things work. Okay, so I'm gonna close this. All right. So here is the actual HTTP request. It's not a ping. It's not a ping. It's a more elaborate request. So this time it says, okay, go to this domain, this computer, okay, which has an IP address I showed you earlier. And then it goes to the resource. This is all the resources. You see that? Up to this is all the resources. Okay. Really up to here. So from ED to all the way here. Okay, so this is where the data is located, the resource is located. Usually is in the folders. So on that computer, there's a subfolder called the ED, and under the ED folder, there's a college scorecard folder. Under that, there's a V1, then slash, and then you have schools.json. Okay, so this tells you we want this to be JSON, because that's the folder contains all the JSON format, data format in JSON format. Okay, so now you know the question mark, right? I don't know if you remember, I mentioned Monday. That means what after that is all parameters. Okay, parameters are coming in key value pairs, if you remember that. Okay, so I'm gonna gradually go there, and you will see there you go. So that's one parameter. The one parameter is school degrees awarded predominant. So that's just key name. Just name the key. So basically, I'm asking, I'm going to go to that government computer, go to this folder, this resources. What I want is I want all these schools that offers predominantly degree type to be 2. Okay, 2 means associate degrees. Okay, so that's just a dictionary you have to know. The government website will provide you with. say, okay, whenever you say 2, means that is 2-year degrees. And then if you say 3, that means the 4-year degrees, means bachelor's degrees. And then if you say 4, that means I think is a graduate degrees. Okay, so that is the one parameter is always comes within a key, an equal sign, and a value. Okay, so but you can have multiple parameters. So there's a second one now with the at and, right, ampersand. So now fields. So it's like a many column. It's like a text data. It's a database with many columns. So fields is ID. So in other words, I want that variable called ID field. Okay, so I want all the school IDs. In other words, okay. I also want school name. The fields, I want 2 fields: ID and the school name. I'm sorry, ID comma school name. That's another parameter. Okay, so fields is ID and school name, and also I want a zip code to be 11790, which is Stony Brook. Okay, so and then that's the third one, right? Then the fourth one is I want all the schools that has a distance of 30 miles from 11790. Okay, so you say, okay, from the radius of Stony Brook, I want the radius of 30 miles, or the schools. I want their ID number. I want their school name. I want the schools only that offer like associate degrees. I think also higher. That means predominantly associate degrees, but it's okay if they offer other degrees. Okay, so and then there's something else you have to provide, because the government wants to keep track of who is actually accessing the server. So in order to download anything, you will need to apply for API key. Okay, so they want to get an idea like who you are. So you have to kind of apply to the website first to get the API key. And the API key, well, you just have to provide your email address. Really, they don't really care who you are. They just want to know your email address. Then they will send that key to you through that email address you provide. And the key value you can see is very long and very is like a hexadecimal number. Not it really just characters. um, alphanumerical characters. You see, that's my API key. Okay, so if you are interested in this, you can also get your API key, and then you can do this. Now, once I did this, right, and then I can use my browser to access that server and retrieve the data. Okay, because I already specified I want the data to be JSON, right? Remember, I before that is .json before the question mark. Okay, so I said, okay, I specified I want a JSON, then the data will come down like this. You see, that's what I have. So if I run this again, you will see that's what I get. Okay, so it all has a key value pair, but it's harder to read because it's like one long string. Okay, so very long string. So you have one, that's the open curly brace that matches this one, right? Then you have a key. The first key is metadata, which is not the true data you are looking for. Is the metadata that describes this bunch of data. So he says, okay, total there are 7 pages. You're gonna get 7 pages of 7 records. I'm sorry, 7 records that matches your criteria, which means 30 miles radius from Stony Brook. Okay, predominantly offering 2-year degree of associate degree. So total, the 7 records. Okay, and then there is a 1 page. Now this is the page 1. That's 0. So it's page 1. Okay, and per page we're gonna have 20 records, but since we only have 7, so 1 page is enough. Okay, so potentially you can have thousands of pages, hundreds of pages, but that will give you 1 page at a time. So you're gonna have to kind of specify which page you want. Okay, so that's called a metadata. Okay, so that gives you an overall summary about this bunch of data coming down from that request. And then after that, that's a second key. Okay, in the second in this hierarchy. So metadata, and then in parallel you have results. Now results, you can already see that is an array. You see that the square bracket there? Okay, that's an array. An array starts there, ends here, right? Okay, now within the array, you're gonna have multiple school objects, right? One is a school with an open curly brace. That's the first one. The school name is the Suffolk County Community College. The ID is a 36395, and this ID is an ID uniquely identify our school. And it turns out there are like about 6,000 of schools. Higher education in the United States, and then every one of them has a unique ID. And now this is not including elementary school or junior high school. And then if you want them, they also have the same system. Okay, so that's what we are asking. We want a predominantly associate degree, so that's the ID. Now that's the first record. Okay, now the school name, that's the second record now. The school name this time is Normal Community College. This is the ID. Third one is Nassau Community College. This is the ID. Then Housatonic Community College. I don't know what that is located. Has ID also. And the Gateway Community College has ID. New York College of Health Professions has ID. And the Island, the Drafting and the Technical Institute has ID. Okay, so now you notice that these are the schools that we retrieved from the government website. So this is hard to read. I can, so what you can do then is you can copy copy this, and then you can go to the many JSON viewer applications programs, but there's an easy one called online JSON viewer, which is this one, right? So what I can do is I paste this here, you see, right? I paste this here, and then I will go to the viewer tab, and then they will organize in a nicer way for us. So this comes out like this. You see, JSON, that is the data, right? And then we have, that's the total. And underneath there, the parallel, there are two keys. One's metadata, we saw that before. So open that. Then those are records underneath it. See, total is 7, page is 0. This is the first page. And each page we can have 20 records. Okay, so this is a default. And then if you don't like 20, and then you can go to that query. You can specify, I want a 40 per page. I want a 10 per page. So you have a dictionary. So you can go to the query, which is the one I showed you here. This is the top one, that you can make all the requests, the one you want. And then here are the results. There's 7 schools here. See, it's an array. And these are the indices. 0 is the first school that I think is a community our school. See, it gives you the school name, gives you the ID, and so on and so forth. Right. So why just this 2? Because that's just what 2 we want. And then there's a ton of information about every school, every university, every college in the country. Okay, and every college is obligated to report the information to the federal government every year. I think, and this is what, December now, right? 2020. So every school supposedly should put every up to last year, end of last year. So all data should be, so every school has one up to a year to update the information, and then also to keep a history. So every year's data is there. So you can specify which year you want. Like in our query, we didn't specify which year. That's because we want the latest. Okay, and but then you can actually specify which year you want, and you can say how many years you want. You can do that as well. So it comes down all like this. You see, that's our school and another school and Norwalk, and then this is National Community College, so on and so forth. Okay, now I can change this. I can say, all right, I'm going up here and I'm say I only want 10 miles. I don't want the 30 miles, right? I want only 10 miles. So now I hit enter, and then I only get one school. There's one community college within 10 miles radius from Stony Brook. You see that? Right? So that's our school. All right. So if we say, hey, I want a 4-year school, right? I don't want just the predominantly 2-year school. So then I will change this number to 3. This is 3. Now, this is a put request. Remember put request? You are sending a request to the server. You can use either put or post, right? Post means the request is embedded in the message, okay, which can be encrypted. But if you do put, then that means the request is actually appended to the URL. So it's viewable, everybody can see, and that's why it's less secure. So it's less amount of information, smaller amount of information is okay. Okay, so this is the put request. All right, so I changed to 3 now, right? So I'm only interested in schools offering predominantly 4-year degrees or higher, and also 10 miles radius from Stony Brook. Okay, now I hit enter, and then now I will get a Stony Brook. It's only one 4-year school within that radius. So if I go to change to say 30, then I'm sure there are more schools will show up, and then there's a whole bunch more. But it's hard to tell how many more, but you can tell there are a total of 15, right? So it's really hard to read something like this. So what you need is you can just copy this and put it into the online JSON viewer. So I copy this, right? So now I go to the formatted version. That's a viewer version. Now you can see the metadata is I have a 15 and 20 per page, and then you can this is the 15 schools, and the first one would be New York Institute of Technology. Then you have University of New Haven. Then you have University of Bridgeport and Yale. Hey, Yale is so close. Stony Brook University and SUNY College of Old Westbury. So they don't make sense. Webb Institute, I don't know what that is. And Fairfield, I've heard of that. That's in Connecticut, I know. And Five Towns, that's nearby. Five Towns, Huntington, I believe, Long Island University, and so on and so forth. So you get an idea. So you can actually get all the details: how many students in each school, what's the tuition, what's the financial aid, what's the SAT requirements, what's the SAT and ACT requirements. Been a long time. So so all these things you can figure out. What's the graduation rate? What's the acceptance rate? What's the ratio of genders and also diversity, and you name it. Okay, so and also security, how many crimes reported in that the school, so on and so forth. So all you need is just know what to search, and because there is a dictionary that allow you to consult it. I didn't download the dictionary, but I can show you now. This is the page. I did a lot of this because I developed an app to market to high school students in the world, because there's a lot of people who apply to colleges in the US. So I have a mobile app developed to market them. So I did a lot of research on this particular case. And then we also had a project 2 years ago, I think, for our 248 students to develop an app, and many people did. So this is the this is some of the relevant information. I'm going to show you something. Here's where you sign up the API key, api.datagov, sign up. Okay, so if I go there, you will see that's where you sign up. See, you provide your name, provide an email address, how we'll use the API, which is optional. You sign up, then they will send you a key. Okay, so you're supposed to have your own key. And then here is another, that's a documentation, right? That's a documentation that tells you the dictionary. Okay, so how to use the database, the data source. So that's documentation, data dictionary, which is amazing if you look at it. Okay, so I don't know if I spend too much time on this, but it's really truly amazing what they are doing. Okay, so this is the dictionary, and dictionary has the README. You can read that, and then you can glossary that has all the terminology uses. Okay, here is the main thing: institution data dictionary. Okay, there you go here. So now you will see. Let me see, move over here. Okay, that's the data structure they have, right? So name of data elements, then each school has a name, institution name, right? And has a ID, is an 8-digit ID and a 6-digit ID, and then you will have institution name, city where it's located, state postcode, zip code, accredited for institution, URL for the institution homepage, predominantly degree awarded. Remember that? That's what that comes from. And then it tells you here, I hope, is an integer. You see that? Is an integer. And then it explains in the documentation that 2 means what, and then whatever value means. There you go. Let me see. I think I have it. It's just hard to see. Okay, so there you go. Maybe I can make it a little bit smaller. Okay, so you can see here. All right, so 2 is, you see the number 2, remember 2? That's our school. Okay, predominantly associate's degree, and 3 is predominantly bachelor's. That's what we did at Stony Brook, right? And 4 is entirely graduate degree granting, so on and so forth. Okay, that's the dictionary. So you need that, and then you can find everything about every school. Okay, let me see. That's the control of institution. There's a lot. Local of institution, degrees of urbanization, latitude, longitude, Carnegie classification. Then you have, okay, that's just the beginning. Look at where I am on the scroll bar. I'm just at the beginning. And flag for historical Black college or university, flag for predominantly Black institution, flag for Alaska Native, you name it, right? Religious affiliation, you name it. So, okay, here is admission rate. Okay, so if you want that kind of information, you can get that. You can get the campuses, what's the 25 percentile SAT score. Okay, so you can get this selectivity, right? And 75 percentile, 25, 75 SAT. That's math, that's the critical reading, that's the writing, and then that's the midpoint, and then that's ACT. So you get an idea. So you can go down, and then you find the graduation rate, you can find the financial aid, you can find the crime. So everything's there. So you just have to know how to query it, and what's the variable name, and then how to query it. Then you can do that. All right, so I think that's, you get an idea how much information is out there. This is just one example for something related to us. Okay, so I'm going to minimize this, and then it has all the documentation how you can use this. You can download that, right? And so I have a ton of other things. Okay, how to get a certificate. Okay, so there's a lot of there's another thing I think I wanted to show you is this. Okay, so this one is the government. That is the front end. Maybe this is a good example. This is the front end. This is a web app. Okay, it's a government web app. You see, it's a nces.ed.gov, and that is the government web app. And then you can use this interface to search for schools based on your criteria. Okay, so for example, you can say, I want to look for Suffolk. Okay, and you can search that, and then you can put the zip code if you want or not. You just show result. That's the only thing I put in, Suffolk, right? Then you know there are a bunch of schools that contain Suffolk in it, so show result, and then you see Eastern Suffolk Posies, Eastern Suffolk Posies, and Oakdale, Riverhead, Brentwood, Beauty Academy, and then you have Southern, Boston, Suffolk University, Western Suffolk Posies. Okay, so you can refine this, and you put a zip code in 11764, and you found, then you will probably just find Suffolk 784. I think it was middle place is 764, I believe. So 784 is a Southern. There you go. See, you found a Southern. Right? So so this is just the front end. So whenever you type in here, you enter in here, I want to say associate degrees. I want to say miles from 11790. So 790. And then miles from, I would say 10 miles from 11790. You see? Right? So you want the associate, bachelor's, you want the public schools only, see? Right? And then you can say show results. Right? So now there's only Suffolk. No. Oh, this contains a Suffolk. I'm sorry. So if I get rid of that and then show results, then you should choose Stony Brook as well. Okay, because that fits the requirement. And then you can do more advanced search. And then you can say tuition, housing on campus or not, application admitted, that's a admission rate, the SAT, and all that. So that's what I did, and did something even fancier, but it's a mobile app. But so what happens is this is the front end. You enter this, and whatever you entered will be grabbed from the text fields, so to speak, and then we'll form that from this, from the query. You know what I'm talking about? So you just grab the data people entered there, and then you can say text field get text, and then you form this, right? Because you know the first part is the same, API data.gov, ED college, whatever. Then you just set different values for the parameters. And then you send out as a query. Then you get all the data back. And then once you get the data back, you will pause them. You will grab the school name, right? And you grab the school name, then you will display here. Display here. Then form a link. Then when you click on the link, then it will show other information there. So that's the app. Now, I hope you see how things work now, right? This is the back end, and the front end is just really collect parameters, and then you form a query, and the query will send to the domain name, and domain name will send back a JSON data, and you just parse the JSON and then display however you want. Does that make sense to you? It makes sense, right? It's quite interesting how things work. Okay, so now that explains why there's so many weather apps out there or traffic or map apps there, because everyone can write an app. Basically, just do the front end, and then you collect the ASCII input from the users, and then you will compile the input, and form a query, which basically is the HTTP. See, that's the HTTP. You see, that's already in there, right? You send over to the server comes back with the JSON, and then you parse the JSON, and you based on the key to get the value, and then you display them on the view for the customers, for the users. Okay, so that's how things work. All the mobile apps, whether it's iOS or JS or your Android or your desktop web application, like web application. This is a web application. You notice that, right? We don't download anything. It's using a browser, so that's a web application. But all use the same protocol, HTTP. In this case, HTTPS, the secure one. Okay, it's quite interesting. It's very interesting, actually. So not just this, you can get the data from places called, I think it's a place called, what's the place that compile data for restaurants? Ever heard of that? Stop, first letter, I
Yelp.
don't remember.
Yelp.
ELP, what is it?
Yelp.
Yelp?
YELP.
Yeah, YELP, right. Yelp that provides all the restaurant or the reviews, right? Review data, and NOAA provides weather, and then there are Google provides the map, all this GPS. Then Google provides GPS, so any place you can send that information out, and then I don't know, anything you can think of, you can use on app is coming from somewhere. Nobody will actually go collect the data themselves. It's all downloaded from a JSON. Okay, so every day we don't notice there's so much going on, and computer sending back and data back and forth. So that's what I'm saying is a whole parallel universe out there. Good. Any questions here? Do you think this is very interesting? Right? And what we didn't do is we didn't do the server piece, right? We would like to do a server piece so we can actually send data ourselves. So our college, for example, they're working on their server. So all the data, like majors we offer, um, any information about our college can also be the data can be retrieved using JSON as well. But I checked with them last year. They said they haven't finished it yet. Okay, so that's called a REST service, representational state, um, representational state. What's T? T is transfer. Okay, transfer. So representational state transfer. I'm sorry. That's the way the name comes from. Okay, that's the contribution of the guy Roy Fielding, and then that's what. So this is just we are using. You understand we're using get, right? This is the retrieve information, but the same idea can be used to post. You can send information over. For one example is when we did the ghost kitchen application, restaurants can post the menus to the server, right? How are you going to post your menu to the server? You just use the postal verb and send out the JSON. Okay, so same thing. You send out the JSON or the restaurant menus and use a post method to send up. And then the server will receive the JSON, parse it, and put it into their data structure. If it is a Java, would it be things like a tree set or tree map and so on and so forth, or into database, most likely into the database. Okay, so then people also can delete, update the menu, delete the menu items, so on and so forth. So that's all can be done by HTTP. Okay, use the 4 common methods, right? Get, put, post, update, delete. Okay, so those are 4, then there's a head, and there is a option. Okay, so those are the how data gets transferred back and forth. Hopefully you have a general idea how things work now with regard to your the applications you see every day, right? So so now what I'm going to show you next is how we do this in Java. Okay, because that's the language we learn, but it doesn't have to be just Java. Could be anything. Okay, could be any language. JSON, JavaScript is okay. You can use any language. But all you need to do is use this query to get the data, parse the data, and then format it and present it. Okay, so if you use a web, would it be JavaScript, HTTP, HTML, and the CSS. Okay, so if you use a Java, you can use a console. You can use a JavaScript. Using JavaFX or using FXML. So so this is independent of the language. As far as the data, the JSON is independent. All right, so I'm going to show you some example. And now what we need is, you understand, we have to have a query, right? And here is the query I wrote. And here's the query. Okay, see, that's the query I just did. HTTPS, that's a URL, see that? Okay, API, HTTPS API.data.gov/ed/college scorecard/v1/schools.json. I want to JSON actually is the default, but if you want XML, I don't know if I can do XML here. Hold on, let me go back, see if I can specify. I think I can do. I don't remember now. So let me see if I can just want XML, okay? Just change this to XML. Okay, so I wanted the XML format. Enter. No, they didn't provide XML. Some do, some don't. Okay, so that's that they don't provide. I'm surprised. I thought they did. Okay, that doesn't matter. So let's go back to look at my Java code. So I want a JSON. I want the same parameters, right? School degrees awarded predominantly 2. I said, right. I'm gonna. It's kind of long. It's a 2. The 2 fields I want. One is ID. One is the school name. ID is unique, and the zip is 11790. Distance is 30 miles. And then that's my API key I showed you earlier, right? That's an API key. So I form a URL, and so that's what I'm going to send my request to, and that's going to be a get. Okay, so I have others too. I have 2, 3, 4. That means 4-year degree and also a graduate degree. Okay. And I also had a Google API. There's a Google for map. Okay, and I also I want some location in Chicago. I think. See, I did the Chicago. I also had to get a API key from Google, so everyone can provide can apply. So I think I have an API key for Google. I didn't paste over here. This is another query. Okay, so that's the URL you need, right? You start with the empty string. That's gonna hold the data. Hold what data? Hold the data coming back. That JSON string. So this is data No, I need to change this to JSON. JSON. Okay, so here's the string. See, here's the string. So I need to pause it, right? So initially I call inline, and it's blank, and then I open the connection. You see, this is the connection. That's how I get the data. Okay, and I specify this is my method. Remember the get method? Okay, that's the one of the verbs, get method. I'm going to open the connection to that location, get the resources, and then I'm going to get the response code. I forgot to talk about the response code yesterday. It was Monday. Okay, response code, if it's a 200, any number 200, in that range, 200, 201, or whatever, then that means normal is success. And 400 means error. Okay, that means the resource cannot be found. I don't know if you go to a website, you get sometimes you don't get anything back because you get a 401 back. Ever heard of that? 401. Have you ever gone? You say you're gonna go to any random website that doesn't say. I just go to random website. So HTTP. Say random, right? So say something like this. So it should give you a 401. It didn't say here. 401 means there's no resource cannot be located or something like it. You can get to the right page. Okay, so maybe I do something like this. Google.com. Then I say some random things, right? HTML. There's no such thing. Okay, so see 404, because Google said I cannot find that resource you're looking for, right? That's 404. That's the code. Okay, see that was not found on the server. Okay, anyway, so go back to here. So 200, anything 200 is normal. 300 is a type of error. 400 means resource not found. So what I'm saying is, let's get that response code to see if this whole query went in successfully or not, right? And we'll say if the response code is not 200, then something went wrong. Then I will say throw runtime exception, say this is the code is say 404, 401. Okay, so that is just like a kind of like exception handling, right? If the response code is not 200, that means something went wrong. If it is 200, then that's good, right? So if it's not 200, we just do this, then we're done. We throw the runtime exception. Okay, else that means is 200. If it is 200, that means it's normal. Then we're going to open that string, URL open string, and we're going to read it. Okay, we're going to read it, and read it with as long as we have a next item, we're going to read it. Okay, we're going to concatenate it into the inline. Initially was blank. Now, as we read more and more items, we concatenate them into the same string. So at this point, I can actually, if I disable everything else, okay, if I display everything else, so see if I can disable this. No, do I have an error message here now? I think I need some brace. Okay, maybe I need another curly brace. No. Maybe get an extra curly brace, doesn't make. No. I just see where I am. So here is the else. Then I need the one for try. So I need it for try and the catch. Where's my catch? Here. So I needed this too. Okay, good. So let me see. That should be okay now. No. So I'm still missing something. Okay, that's okay. That's the fine. That's fine, right? So up to this point, once I finish the while loop, that means I read in every single data items, and I concatenate them into one string called inline. Then all I'm going to do is just print out that line. And what you're going to see is the same thing you're going to see on the browser. Okay, so watch. I'm going to run this now. I'm going to run this and print out the see? That's the string. 7 items, 20 per page. See everything. The software community college is the first one. This is the ID and all the schools. See? So Java now can actually retrieve the data from the server, right? But it's in the format very hard for Java to understand. You understand that, right? You can see that? Because this is the one string. So the next step is you have to parse the string and try to make sense out of it. Do you understand? So far, all you're getting is just a long string that contains data coming back from the server, which is a JSON format. Do you understand? Okay, so once I get the inline out, then I will close the connection. Okay, close connection. Now I'm going to enable these guys. Okay, now these guys are varies. Okay, what I used in this example, I use something called the Jackson. Okay, Jackson is a JSON parser that allow you to parse JSON objects into Java object. Okay, it's called Jackson. So Jackson is a library you can download. So I'm going to show you what I did. So it has 3 things you need. Okay, so let me see if I will have it here. Here are the 3 things. Okay, these are 3 things. One is called jackson.annotations.jar. You need that. And you need the jackson.core.jar, and then finally you need jackson.databind.jar. So all the 3 jar files needs to be downloaded, and once you download it, you just add to your project. See, you go to build a path, right? Go to build a path, go to configure build a path, and you see, go to class libraries, go to class path, then you add those 2 jar files by doing add external jars. Okay, then you add those 3 things, and then you say okay, then they're added. It's just same like what we did before last week. Do you remember what we did last week? What we add? We add the SQLite driver. Remember that driver, the jar file, SQLite driver, so you can understand the database, right? So, but this time, since I'm using Jackson, so I have to do all this. Okay. Now this is kind of awkward because you have to go online, you have to go to the browser, you have to download it. But there is an easy way I didn't talk about. I regret. That is, I'm going to just show you briefly. There's something called a Maven. Okay, this is called a Maven. So I'm going to kind of show you what that is about, right? You go to see, this is my file, right? I create a new project, and then you can go to other. Okay, then you're going to see there's a Maven. Okay, see this Maven. Okay, see, now you can create a Maven project. Right? So when you create a Maven project, I highlight a Maven project here, right? So I'm going to give a name. So next, okay, so create a new Maven project. I'm going to say, I don't want to use this name. Okay, let me cancel this, do it from new one, new place, okay? So I'm just going to create a new project from scratch. But this time I'll create a new Maven project. I don't want to impose onto this existing one. Okay, so I'm just create a new one. Java new. I think I just go to new and go to other. Go to Maven. Okay, go to Maven project. and then you say next, and then browse. Why go to there? I want to create a simple project skip in the type section. Use the default workspace location. Add a project to work set. I don't want to really put in there. So I'm going to put this in here, say my Maven project. Okay, so you just create a new one. Then you say select a folder. It should create one for me. No, it doesn't create one for me. So in that case, then I have to do a. I just put it inside there. So even if I do next, and then the set archetype, I don't have to do anything. Just use artifact ID. Just use the default one. It's fine. We just use some default one. I don't think you have to pick any particular one. Yeah, use some GitHub. Which one I used to use? I don't remember now. I don't remember which one I use. It seems to me that's the NetBeans Java Faces. I don't want to use that one. I don't remember which one I used to use. Okay, so I'm not going to get into it because I'm running out of time. So what this does to you is you have to do a little bit reading documentation. What that does to you is you create a Maven project, then you have a file called POM file, POM file. That's where you can copy paste some kind of instruction. So when you start the Java project, then the Java project knows by reading the POM file, knows to download the appropriate compatible library jar files. Okay, the 3 jar files we need. So he knows to go to the right place, find the right versions, compatible versions, and do it. So that's really a very nice tool, right? But I don't have it for you. We used to do it in other class in some other semesters. But anyway, so we're going back to here. I'm going back to here, and then now I download all that and I added the library which I showed you before, right? I showed you that. So just the 3 things. This is a more build path. It's a more tedious way. You have to enter manually. Sometimes there's a conflict. So have you read the documentation, make sure that there's no conflict. Okay, so I added them, so they're there. So once I add them, then I can use something called the object mapper class. That comes from the Jackson. So if I open the import, you see that's from Jackson bind. It's called the data bind. It's an object mapper. So the mapper allows you to map the JSON object to Java object, really. Okay, so what are you going to do is you read the results. You see, that's the key. Okay, you read the value from the inline. That's a string. That's the JSON string. Remember the inline is the JSON string I printed out before. And then read that in. And then you will only get the node that called the results because the metadata, we don't care. We care about the school, right? So that's results. And it's an array. We know that. Okay, you know it's an array. And then you go through the array, you get each one gets the key and gets the value. You get the school name, you get the ID, and you make a JSON node. Okay, the JSON node. And then you can get the metadata also, you see. You put them in the data field, total. So you can retrieve all the data by using the method get. Okay, the get will give you for the each JSON node, if you give the key value, it will return the, if you give the key, it will return the value. So you can get everything like that. Okay, now once you get the data, obviously, now you see you have the total, you have the school name, you see, school ID, school name. Now you can form your Java object by using constructors. So that's how you parse. You parse your JSON, and then you retrieve the value by reading the key value, and then you make the values, then create an object. So I'm going to run this program, and you will see it looks like this. So first of all, I will disable this printout because that's just I can leave it there. That's just the one we saw earlier. So I'm gonna run it, and then you will see. This is that string, that inline, very long string, right? Unparsed. This is the parsed version. See, provides the school name ID, school name ID, school name ID. So which is the array. And in the very end, provides the metadata. Total is 7, page is 0, per page is 20. Okay, so that's how you retrieve data from JSON by reading each key to get its value. In this case, it's JSON. In addition, there are tens, at least tens of Java, or just say JSON parsers, okay, for all kinds of languages. Jackson is one, and then one is JSON. That's the Google one. And then there is a JSON. I think that's the JSON object. Oh my God, there's like tens of JSON parsers. Okay, JSON is the one that's from Google. See, and there's so many. There's so many, and so common ones are JSON and Jackson, and then there's a whole bunch of a handful of others. Okay, so using JSON parser, there's a JSON parser, it's deprecated. JSON parser, JSON parser online. So there's the online one. This is another one, just a JSON parser. So that will allow you to read, to understand as well. So from the server, you get that from the server, you use the get method and array. So anyway, this is so much out there. But the whole idea is, there was a program there, library there, that will allow you to parse your JSON into Java objects, or into any objects if you like. Okay, there's corresponding parsers for different other different languages. But JavaScript is actually native. Okay, JavaScript has its own parser that's native because JSON is JavaScript based. So you don't need another library. Yeah. Okay, so that's why JavaScript is so popular for web application, because that's one of the reasons. All right. Then there's a stringify. Stringify means when you have a Java object, okay, then the Jackson or JSON has a method called a stringify, that will turn your Java object into JSON object. Right? You need both, right? Sometimes you need to stringify, sometimes you have to parse. So this is the opposite of the same story, right? So one is JavaScript function, JSON, stringify. Java has that as well, stringify. Okay, stringify and a parser. So those are two things that on two different ends. All right, I think that's it. Just a general impression what this is about. Okay, so then we have a little bit of time. we're going to talk about multi-threading, just show you some of the multi-threading programs. So you get an idea what it's like to have such a concept at least. All right. All right, let me find my notes for multi-threading. It's very interesting. Let me see if I can get my notes for that. Multi-threading, where is it? Here you go. Here it is. Okay, so we'll start a new project and then we're going to do it. 10, 11. Usually we'll take 2 or 3 lectures to do, but I'm gonna just show you some basic stuff. Just give you an idea what it's about. Okay. I'm gonna do something like this. Okay. So let me close all these. I don't need any of this now. And then I'm going to start our project, close all this, and then I'm going to create a new project. And then I'm going to call this multi-threading. All right, multi-threading. And then I'm going to make this a little bit smaller. And then I'm going to create a package, P1, like just that's good enough. Okay, so I'm gonna have one class. I'm gonna call this. I'm gonna call this because I have different things. Okay, I'm gonna call it demo one. How about that? Just demo one. Yeah, fine. Demo one. Okay, so this is a normal main method, right? You understand? For all these 2 years, when writing code, we go like this, right? Hi, hi, and then if I have something else, I would say, I have it. Okay, so if you do something like this, right, we understand that anything you put into the main method is executed sequentially. Okay, so it's guaranteed that you will do statement 6 first. When that's finished, you do statement 7, right? So the reason is because the whole program is submitted to the CPU, to the processor, as one unit. So the processor will allocate a fraction of its time, okay, to try to run this program. And then we'll start from the beginning of this main method. And when you finish the one statement, then you move on to the next one, and then the next one, next one, next one. So that's totally sequential because the whole program is controlled, is executed by one processor, by one what we call thread. by one thread. Okay, that's the amount of time the processor allocate to this program. So you may have the impression that you can run many programs at the same time, okay, but it's really never running at the same time. Okay, it's all because the processor is processing data so fast. So each program get a very small slice of a time uh, at a very fast pace. So when it feels to humans feel that the program is running nonstop, but actually it's not. It's all running by time slots. So you get a fraction of a second, and then the CPU will go deal with another program. Give that program a fraction of a second, then move on to another program, then comes back to the first program. Okay, so it creates that illusion that the CPU is helping you all the time, but it's not. Okay, it's not. So it's like a video is made of a lot of small static, like photos, still photos. But if you show the still photos is such a fast pace, then you create the motion, right? So that's the same thing. So that's called a single thread. Okay, that's all been doing single thread. Now, in order to do multi-thread, then what we have to do is we have many ways to do it. One way is we create a class. Okay, we create a class. We can call whatever we want, just the class. So I'm going to call runner. But the most important thing is, okay, so I just called a runner class. The most important thing is you're going to say extends. Okay, extend thread. The super class extend thread. Okay, so if you have a class, whatever you call it, if you extend thread, then that class will be executed in its own thread. In other words, that will get its own time slice of the CPU. Okay, so then specifically, what you have to do is you have to enwrap whatever you want to do into a method, just as usual, and the method has to be called run. Okay, the method has to be called run. The method header has to be public void. No argument in the run method, nothing returns, so it's void and it's public. So anything you put inside here is going to be executed in its own thread. Okay, so that's the idea. So now if I want to say sys out, right? I'm going to say what? I'm going to say hello. Okay, I'm going to say hello, and then I'm going to say something. I'm going to enwrap this into a loop. Watch. I'm going to put this in. So I'm going to say hello many times, in other words. So I'm going to say for loop. So I'm going to say how many times? So I'm going to say 5 times, right? And then I'm going to add I to it. So first time is 0, then it's going to be 1 and 2 and 3 and 4. So I'm going to say hello 5 times, put it in the loop, and then but the thing is, once I say hi, hello once, every time when I say hi or hello, what I'm going to do is I'm going to put a thread dot sleep. So I'm going to put the thread into sleep. Okay, because if I don't put in the sleep, then the 5 hellos will come out very quickly. Okay, one slice is more than enough to do that 5 hello. So I purposefully slow down this. I put a 100 milliseconds. I want to delay the hello. So the same thread will say hello, we'll put into sleep for 100 milliseconds, 0.1 second. And then we'll keep on say hello again and then put it into sleep again. But you have to do a try catch for the sleep, just in case another program, another method try to wake it up. So you say, what is going to happen? You're going to do just to put out the error message. So that's all you want, right? That means this for loop is going to run in 5 times, and it's going to run in its own thread. Okay, so that's going to be different from the from the main thread. That's the main thread. Now I'm going to actually use it. So I say new runner, okay, runner, and then start. So remember that method called start. So what you're saying is, let's run that start means start a new thread. So you always have to remember using the .start method to start a new thread to execute that run method. Okay, so that's the right way to do it. However, you might attempt to do this because there is a run method in the run run class, right? By doing this, you're not going to create a new thread. Okay, you just purely run that run method from the run class using the same thread of the main thread. Okay, so if I do this, you're not going to run on two different threads. It's really just one thread. That's the main thread. So to actually use a new thread, you have to say start. Okay, then you're starting a new thread. Okay, so now watch. Here is my main thread, right? I say done. Okay, so this is my main thread is going to do. My main thread will start a new thread. The new thread will say hello 5 times, right? And the main thread will also say done. So now there are two threads. Main thread will start a new thread, say done. But the new thread will say hello 5 times. You got it? Okay, there are two threads in this case. So now if I run the program, you will see something like this. You see something unusual? What do you see? What is unusual here?
The main thread is the priority.
Well, of course, main thread starts first, right? That's for sure. That's where everything starts from main, right? So what's unusual about this outcome, this output?
The done was printed before the hellos.
Yes. Is it done? That means the main thread already finished because done is the last statement of the main thread, right? So the main thread is actually finished, but the new thread actually is still ongoing and printing hello, right? But if I don't sleep, if I don't put this into sleep, okay? If I don't put into sleep, what's going to happen is, okay, you may not even happen like that way, right? Because okay, this happened because even that without sleeping, okay, the main thread still finished the faster than the new thread. Okay, so so that shows you indeed there are two threads going on, but but now if I do something like this, watch. If I do something like this, you see the difference? Because you're not creating a new thread. Instead, you just go execute this method that will give you 5 hellos. Then when it's all done, then you go to line 7 and say done. So that's one single thread. But you change to start, you have the two threads. Okay, so that tells you that you can have multiple threads, and the key is wrap what we want to do in a new thread into a run method. Okay, into the run method, and then this sleep is just make it more obvious. Okay, now I'm going to do something like this even. So I can start yet a new thread with another new thread. So altogether, I have 3 threads: main thread, and then the 2 new threads here. So you will see something like that. You see? Hello, 0, 0, 0. Those are for 2 separate threads. So the first thread is not done because he's only set a 0. Then you have to say 1 and 2 and 3 and 4. But then the second new thread actually stepped in, said hello 0. Okay, so the 3 threads going on. This is the main thread. This is the first thread. This is the second new thread. First new thread. This is the second new thread. Okay, so that shows you how to do anything into a new thread. But all you need is just remember to put them into the run method. Okay, now I'm going to show you the more common one. This is not the most common one, but I'm going to show you the most common one. Because if you do this way, you have to remember to write the run method. But I want to show you. Where is it? I want to show you some common one. How much time? I have 10 minutes. This I would like to show you this if possible. More common one. Block over here. And then okay, I don't have the note for it, but I can show you how to do it. Order queue. Okay, so I can just show you from my memory. So I'm gonna go to P2. Go to P2, so package 2. Okay, so this is the more common one. So what you do is you create a new class, okay, like usual, and you can call it runner if you want. And then you're gonna say finish. But now what you want to do is, last time, remember we said extends thread, right? So this time we say implements runnable. Okay, so when you do implement runnable, then you're gonna have to implement a run method. So this is force you to implement the run method. See, that's the run method. So now everything you put into here will be in its own thread. Okay, so now I'm going to do the same thing, right? I'm going to say sys out, and then we're going to say hello, and then I'm going to surround this with a for loop. And I'm going to do this, say 3 times, and then I'm going to just say plus I. Okay, so every time I'm going to put into sleep, thread dot sleep, and then you're going to say 100 or 10 milliseconds. Okay, let's try catch. Okay, so that's, otherwise it's the same. Okay, so that's how I do the runner. Okay, so now I'm going back and create a new demo. I'm going to call it demo 2. Okay, so demo 2 name. Now here is what I'm going to do. You can say thread, okay, and thread 1 equals new thread, and then here you're going to put down the runnable. See, you take the runnable, which is a new runner. Okay, so now you have a T1. So in other words, you, instead of create a thread class or subclass of a thread, you create a subclass of the runnable. Okay, and the runnable, it turns out, is a is a functional interface. Okay, so it has a method called run. So when you implement that, then you have to implement the run method. So once you have that, you just have to say t1 dot start again. Okay, then you have to sys out, and then you say the, just like we did before, right? So when you run this, you will do the same thing. See, 100 from 0 to 99, and done happens first. Okay, so it's really the same thing. So you can have 2 of this. Okay, so now T2. And then I'm gonna say T2 dot start. Okay. So now I'm gonna say done or so. So you can do this in 2 separate threads. See, 99, 98, 96, 95, and so on and so forth. Okay, now you can do something like this even. You can say T1 dot join. Okay, then in this case, I'll show you what that means. Surrounded try catch. Okay, then you're gonna say T2 dot join. Okay, so what that means is this. This will start 2 new threads, right? Right, start 2 new threads. However, though, you will let the 2 new threads to finish. Okay, so until you wait until the 2 new threads finishes, then you reactivate your main thread. So this will guarantee your done will be finished last. Okay, so sometimes you need the data coming out from 2 different threads or another thread before you can finish your main method. Then you use a join to wait. Right, so let me show you what happens. So you will see the done comes out in the very end. Right, you see that? And you see the numbers are all messed up, you see? Why they're all messed up? Is the sequence numbers all messed up? Why? Because the 2 new threads are not in sync, right? Okay, so some new threads get ahead of the other new thread. So that's why they're not in sync. So the 99 for one thread is already finished way before until another thread finished 99. You see, they're not really in sync, the new threads, but they all finished 99. Okay, so if I go back and change this to 10, maybe it's easy to see. You may or may not cause that same effect. So see, that's all in sync. 4, 4, 6, 7, 8. Right, so that's easy to be in sync. There's a fewer number, but the point is, the main gets finished the last. Okay, so that is now. What's the use of this? Right, just a couple of minutes. Your program can be more efficient. Right, so what I'm talking about is this. When you have a computer, you're running many tasks at the same time, right? So let me see you Control Alt Delete, I think is. Use the Windows Task Manager. Okay, you see this, right? You see all this by each of this is a different thread. Okay, they're all running at the same time. See, all those tasks are running. So the CPU is allocate a slice of time for each of those tasks. Okay, so if you have a one single thread, like a single thread program, so you'll be one of this. In other words, the CPU will allocate one slice to you. But if you write a multiple thread program like this, then the CPU will allocate 3 slices time to your program. One slice to run this, one slice to run this, one slice to run the main. So in other words, you can gain more time, okay, for this program, right? So so what's the point of that? For example, a very common example is people try to hack into another computer by guessing the password, right? How you guess the password, the most common way is try to feed the dictionary to the login screen. So this way you try from the first word from the dictionary until the last word from the dictionary, right? So what you can do is then you can divide the dictionary from A to M, and then all the words A to M is one thread, N to Z is another thread, right? So now you can try to hack up twice the speed. Okay, so one thread will try all the words from A to M, another thread will try all the passwords from N to Z, or you can do multiple, more than that. You can like 4 threads or 10 threads. So overall, because you are using so many different threads, so overall you could finish the trial, the whole dictionary faster. Okay, another example, of course, is going back to our GUI, right? So if I show you a GUI program, do I have a GUI program somewhere? There's a sim builder. Let me see if I have a GUI program. Here's a GUI program, right? So remember I had this database, yeah, the main, right? Remember the GUI program, okay? So when I run this, and you see there is the main thread running, and then there's another thread waiting for me to take care of the GUI portion of it. See, the another thread is still waiting, and then you can do things. So this is multi-threading going on, even if the main is finished. So I don't like just to give you an example here. So let me create a new, just a simple new package. Okay, just say multi-threads. Okay, so that's the name of the package. And then I'm going to just create a main demo. Okay, main demo. And then I'm going to do the GUI one. So extends application Then I'm going to do this start method. And here I just say launch args. Sorry. Here args. And then I'm going to just say sys out, just say hello. Okay, so that's a very simple GUI program. I have a stage. I can be anything. You can say stage. Okay, then you can even say stage.show. All right, it's a very simple program, but I just show you this is a multi-thread. So see, the main one starts the launch, right? Launch starts the start, and the starts thread starts a new thread that is controls the stage. So stage is controlled by a new thread you don't see. So let me show you. The GUI part is controlled by the new thread. So watch. When I open this, I need to put that VM argument there. So let me copy this and then go into the run configurations and main demo arc. No, that's the one. Yes. Oops. XML, I think. Yeah, that mistake. Apply, run. Now you see. So this is the window, the stage, right? This is my stage. That's GUI. So that's its own thread, and the main is already finished. You see, the hello is already there, and see this one, or even even you can say put a hello behind it. Copy by. I'm gonna say by. Let me restart the program. So hello, bye, and this is the stage. So now you can see hello bye. It tells you the main thread is already finished. However, there's another thread running, you see? That is the new thread. So the GUI is controlled by a new thread in addition to the main thread. So that's one application we've been using all the time, but we never really talked about it. Okay, so that's how it's implemented. It is very interesting, but just to get an idea today, we won't have time to go into the details. There's a lot of other things you can talk about, and then since this is a where's my multi-thread here? Since this is a functional interface, so you can already do things like this. So you can do P3, right? Package P3, and now close everything. And then now I just have a main. Okay, watch. I'm gonna have a main class. So main demo, right? And that's all I do. Over here, I just say thread t1 equals new thread, right? Froze. Okay, so new thread. Okay, so what's inside here needs to be a runnable object, right? Okay, then, but runnable is a functional interface, so you can say something like this. You can say e, because that's a run method, right? Run method has, oh no, run method doesn't even have to have anything. Run method has no argument. So now you can just say curly brace, why I have this, okay, this. Okay, so thread, this one, no, I don't need this one. Now I think it's good, yeah. So that's, I don't know if you get it. So basically is doing like this. That's the original one, right? So I need a runnable object. How do I do that? Runnable object is a functional interface. It has only one method, is run. The run method has no argument, so I put the parentheses with nothing in it. And the method body is indicated by the arrow, and then the curly brace. So inside of here is the body of the method. See, that's the body of the run method, and the method will say sysout. Okay, sysout. Then you say hello, and then if you want to put it into a loop, you can do that. Okay, so into a surround with a what is going on? Put in this. Why didn't give me the option? So, that's interesting. No, this is the wrong one. I don't need this one. So do hello, and then that being a new thread, and then that's it. So all I need is t1 dot start. Okay, then there's t1 dot join, means I'm gonna wait, and then my main thread is out, and just say main thread is done. Okay, and now once you say hello, actually put it into sleep first. Dot sleep, and you can put a 1 second to sleep, and then put a try catch. Okay, so T1 join, T1 start, add a throw, try catch. Okay. All right, so I hope you can follow me. So I don't create a new class like last time. No runner, right? No need to have a runner because I use a normal expression. So I create, it's like an anonymous class. And then inside there, I just implement the method of the main. And the new thread will sleep for a second, and then we'll say hello. Okay. and then we're gonna wait, and then the main thread is done. So that finish last. So if I don't wait, then the done should be done finished first. This will be first. The main thread will finish because you're not you asleep 1 second there. So I will see main thread is done. Second later, hello, right? But if I join, then that means you will wait until hello finishes to then say done. See, hello, then main thread is done. So you can control which one gets finished first. All right, so this is most commonly used because you can create as many threads as you like in place whenever you need it. Whenever you need it. So if you want to develop this application to have multiple threads to allow login, multiple people to log in at the same time, that's how you do it. Okay. Whenever people log in, create a new thread. Whenever there's new people log in, create a new thread to deal with that login. Okay. So all the web servers, they all multi-threaded. So a web server allow multiple people to get in, right, to view the pages, right? But during the priority registration, sometimes it crowded the server, and then some people cannot get on. You get a message saying too many users using it. That's because there's not enough threads to take care of that many users at that moment. So you're gonna have to wait until somebody get off, then that thread gets killed. Then you have a new user can get the thread. So it's actually very common, very popular. So you can have as many threads as you like. You can just create yet another new thread. Okay, so you can say thread 2. You can say sleep, say 5 seconds, and then you would say bye. Okay? And then of course you always remember you have to use a start because that's how you start a new thread. Okay, so run again, and then it's a bye first because of 2 milliseconds, then hello because that's 100 milliseconds. So that all right, so that's it for today. You have any questions? It's very exciting. Unfortunately, we don't have too much time talking about it.
Just a question. So what's the question gonna look like on the test? Like with
Well, it
what we
will
did?
be, if there is a multi-thread question, will be something like this: how to create a new thread and do something on new thread. You can use either one of the 3 approaches. One is to create a thread subclass to do it, like this first way. So this is the thread subclass. You see this, or the second way, which is a runnable subclass, but it's a separate class anyway. Or the third one, which is number expression. You don't create a separate class. Okay, so this is very simple because all it says is hello, but this could be a method. This could be a bunch of methods. You can do a lot of things in its own thread, right? You can do a lot of things in its own thread. Anything you want to do in single thread, you can do in multiple threads. But of course, there's something we didn't talk about, is synchronization, right? Because ultimately, all the different threads that may produce data at different time, then you may want to synchronize them, because if you need the data from the second thread, you have to wait the second thread to finish, right? To be able to get the data. Otherwise, data is not there yet. So there's a mechanism for one thread to wait, okay, before it starts another thread. So it's a very, very interesting topic. It's very useful, especially today, because today our computers are multi-core, like quad-core, right? 8-core computers, the processors. So they can actually take a good advantage of multi-threads. They can allocate a core to each thread. So that's why it's so popular, so useful today. I know you can't wait anymore. You're tired. All right, but so we touched upon a lot of things today. So there's no real burden on your side on the exam, right? I do understand, it's very fast, but I feel there's important things I want to show you, to see how these things work. So you can put on the resume, so you have some knowledge of multi-threading, what that works, how that works. You also know the REST service, the JSON, how data gets transmitted between computers. In addition to HTML, CSS, and you have a protocol like JSON and all the verbs, like up, put, and post, and get, and delete. All those methods you can use to apply to the data, the nouns in the JSON. So I thought it was interesting, and then when you at work in the future, you can, of course, you must look into it and get more detailed information. But this is just a start. All right. So I guess if you don't have questions, I will see you Monday. Yes.
So I just had a quick question. I'm sorry, I came in a
Okay.
little late today because I was finishing a test. For
Mhm.
our final exam, when
Mhm.
is that